Very cool. Brilliant. So, hi everyone. Welcome to the first SEN seminar in 2026. It is really, really lovely to see so many of you again. And I'm very, very happy and excited to host Professor David Shanks today. David is a professor of psychology at UCL, and he's also Deputy Dean in the Faculty of Brain Sciences. His work looks at how we learn, how we remember, and how we make decisions, including some really fascinating questions around unconscious learning and how our minds work. He's published extensively in leading journals of cognitive psychology, and he's also co-author of a book called Open-Minded, which takes a thoughtful and refreshingly skeptical look at what we think we know about awareness. His talk today is titled Interleaving in Inductive Learning, Causes and Interventions for Metacognitive Unawareness. So without further ado, David, thank you so much for giving us your time today. We're very excited.
Yeah, thank you. Complete pleasure. Um, right, does that work?
Yes, we can see your screen.
And you can see them sort of full slide, or are they?
It's in presentation mode. It's not in presentation mode. We can see the slides on the side as well.
How about that?
There, that's full screen.
Is that okay?
Yeah, perfect.
Good, great. Larry, thank you very much indeed. Um, so yeah, this is some work that I've been involved in for a little while on this interesting property of learning in relation to interleaved materials. And this is work that's been collaborative with Chunliang Yang, who's in this photo on my right, left as you look at it. Chunliang was a PhD student here at UCL until about 2017, and then went back to Beijing Normal, where he is now on the faculty and is growing a very impressive research group, which you can see here. This photo was taken in June when I went to China, in fact, with a group from the IOE, including Liori. We had a great time there. And this is some of the fabulous people in Chunliang's group. And at the bottom left is Muzi, who's a student who led some of the more recent work that I'm going to talk about. By the way, please, I mean, if there's a question or anything that comes up, by all means, shout out or get my attention or something, particularly if it's about methods. Okay. All right. So I thought about giving you a little quiz, but in the end, I decided that I'd just show you the results because you're probably not a very naive audience. But I'd like you to just think about this thought experiment. So we're going to have two different classes, and these are sort of, I guess, art history classes. Students are trying to learn to identify artists' styles. And in class X, what's going to happen is that the students are going to be shown 6 paintings by artist one, each of them, labeled with the artist's name, and they can look at those and try and learn the artist's characteristic style. Then they'll have 6 paintings by artist two, and et cetera, et cetera. So this is a blocked presentation. You have a block of paintings by one artist, and then you go on to a bunch of paintings by the next artist, and so on. In class Y, in the other class, the same materials are presented, but now in an interleaved fashion. So you get one painting by artist one, and then you get a painting by artist two, and a painting by artist three, and a painting by artist four, et cetera, until you get back round and you see another painting by artist one, et cetera, et cetera. So here it's all interleaved. And then what we're going to do, in order to see how much people have learned about these artists' styles, we're then going to present a whole bunch of new paintings by these artists, and they have to classify them. And we just look at how good they are now at generalizing to these new paintings. So I hope the setup there is comprehensible. And I invite you to think about which of these methods you think might be more effective for learning, the blocked or the interleaved condition. And I was gonna run a little Mentimeter quiz, but if you've read the abstract, you probably know the answer. I won't bother to do that. But I invite you to think. I mean, that both options seem plausible, and in particular, I think the blocked option seems plausible because um, jumping from one artist to another might really be quite difficult. Whereas when you get them in a blocked order, you have much more of an opportunity to learn what's common to a particular artist. Anyway, I mean, I showed this exact text to students on the BSc psychology, taking a course that I teach on learning and memory. So they're students who ought to have at least some, I mean, they're final year undergraduates, so they ought to have at least some sophistication about learning methods. And what I found was that they were almost completely perfectly split between the interleaving and the blocking strategy. Okay, so 28 thought that interleaving was better, and 24 was thought that blocking was going to be better. Okay, so why is this interesting? It's interesting because the evidence is pretty overwhelming that interleaving is advantageous, and I'll show you some evidence for that throughout the talk. But at the same time, and as kind of emphasized, I suppose, by these data, people don't seem to be terribly well aware. They don't have a great deal of insight into this advantage. And I'll show you that the advantage is really quite large in most of the situations that have been tested. So the talk really, I mean, my talk really isn't about why you get an interleaving benefit. It's about why people's metacognitions seem to be so biased and erroneous. Okay. So just to prove to you initially that the effect is real, this is a meta-analysis. This was done in 2019. I mean, since then, there would have been dozens and dozens more studies on this. But Brunmeier and Richter in 2019 found 238 studies or 238 comparisons. These are usually within subjects comparisons. And you can see that they get a very healthy effect size here. G is a slightly corrected version of Cohen's D. So think of these as standard deviation units, basically. So about nearly half a standard deviation benefit of learning via the interleave method compared to the blocked method, highly significant, and so on. Um, you can see that they also were able to break the meta-analysis down by various types. And largely speaking, across all the types that they looked at, they saw a common pattern. There's a bit of an outlier here, the word stimuli, which seems bizarrely to show a negative effect. I think there are probably some weird things going on there. And as you can see, it's a very small sample of studies. Um, but by and large, many kinds of materials yield an interleaving benefit. And I should just say that although I'm really going to be talking about inductive category learning, um, this effect does generalize to other kinds of learning, particularly things that are important in the classroom, such as learning math skills, learning different maths procedures or rules. Nice research showing very clearly that interleaving different kind of rules, different methods from one problem to another one is a better way of learning than having sort of three or four or five maths problems all on the same principle and then switching to the next principle and so on. And similarly around aspects of literacy, including spelling and so on. Okay. So as I'm not really going to be talking that much about why you get an interleaving benefit, but I will just say that um, probably the explanation of why you get this benefit is something to do with within versus between category similarity. It's something to do with, I mean, if you think about learning artists' styles, the paintings from a given artist have some quite high degree of internal similarity, and presumably, usually, the similarity of paintings from one artist to another is lower. And and so in the blocked condition, where you're going from one painting to another by the same artist, it's probably drawing your attention to similarities across those artists' paintings. But it's not really the similarities within the category that are most important for learning. What's most important for learning is the differences between the categories. And you need to switch from one category to another in order to have your attention sort of drawn to the differences. And so, of course, you get much more of that in the interleaving case. Okay, so I've already sort of indicated that people's metacognition tends not to be very well aligned in these sorts of experiments with reality. Let me just show you some initial data from one of our experiments just to corroborate that under slightly more formal conditions, and then I'm going to develop that line of evidence a bit more. So in this study, excuse me, in this study we had people learning artist styles. This is, I mean, we were actually using the materials from one of the earliest studies on this by Cornell and Bjork. So here are 6 paintings by one artist, and so participants in the blocked condition would see those, and then they would see 6 by the next artist, and so on. And within subjects, we compared that to the interleaved condition where each picture is by a different artist. Um, Just to clarify on the procedure here, I mean, what participants are seeing on each trial is something like this. You just get a painting with the artist's name indicated. They study that for as long as they want, and they press a button when they want to go on to the next stimulus. And that can be either by the same artist or by a different artist. So you're just trying to learn something or deduce something about the artist's style and so on. And then you go into the test. So in this experiment, this was done in China with the participants here are students. They're learning 12 artists exactly in the way that I've described. They then go into the test phase where they have 48 new examples from all of the artists for per artist. So they haven't seen these test pictures at all before, and they have to try and classify them. And then we ask them, which strategy do you think is more effective, blocked, about the same, or interleaved? Now, right, so here are the data. There's actually data here from several experiments. Um, just focus on these 2 columns here. These experiments are basically all identical. And what they show is that in all of these experiments, interleaving yields better performance in the test than blocking. By about 10%, you see the difference is shown in this column here. These are all significant. So you get, I mean, I mentioned it's quite a large effect. I mean, it's large as a standardized effect size, about half a standard deviation, and it's large in percentage terms. 10% boost in accuracy is quite a substantial um, effect. Right, so that's the basic interleaving effect. And then here is the metacognitive awareness. And this, I hope, now will just confirm to you that indeed, on average, participants don't seem to appreciate this interleaving benefit. And this is, by the way, I mean, this is after the participants have been through the experiment. So if anything, they've had an opportunity to experience these 2 schedules. They've done better in one than the other. But when asked which one they think is better, they don't seem to appreciate that. The majority, about three-quarters of participants, think that blocking is more effective than interleaving. All right, so now we then wanted to ask, so our focus is really on this metacognitive aspect of this. And we wanted to ask, where does this bias come from? Is it something that shows a developmental trajectory? So I'm going to now go to some developmental work where we've looked at children of different ages to see if there is a trajectory regarding this metacognitive bias. And then I'm going to go on and tell you about some studies that we've done where we've tried to look at the kinds of environmental factors that might contribute to the developmental trajectory that I'm going to show you. So in this experiment, we've now got we switched to penguin species. So these are different species of penguins that come either blocked or interleaved. So in this case, there's 5 penguin species. These have weird names, don't they? Like um, macaroni, isn't that a species of penguin? Chinstrap. And so we have children learning these, and obviously we have the blocked and the interleaved ways of presenting them done within subjects, with some species learned in a blocked manner and some learned in an interleaved manner. These children are in grades 1, 3, and 5, so they're about age 6 in grade 1 to about 11 in grade 5. They're children in China again. They learn the species and then they're tested on new exemplars from all of the species. And then again, we ask them about their metacognition. And this is now looking at the classification performance, and we replicate the interleaving effect here. So at all ages, there's a benefit for interleaved over blocked presentation. And in fact, although although accuracy gets a bit better, as you would expect, the older children do a bit better overall. The interaction here actually isn't significant. So there's not really much evidence that the interleaving effect itself is changing much with age. But what does appear to be changing with age is metacognitive bias, which seems to be getting worse, if anything. You can see on the green. So this is the frequency with which children at different grades choose the blocked versus the interleaved strategy in response to this question. And there actually is a significant interaction here. So if anything, the tendency for children to believe that interleaving is worse than blocking amplifies across ages. And that's kind of interesting and prompted us to think, well, what kind of influences might there be in the environment which might be behind that tendency? And I'll come on to that in a moment. But let me next go on to just look at a different sort of way of probing metacognition here. So here we're asking children, like in the previous experiment, we're asking people to respond to this question. And that's fine. That's probably a valid way of getting at their metacognitive knowledge. But at least as interesting, if not more interesting, is to look at metacognition through self-regulated strategies. What would somebody actually do if they were given the opportunity to choose how they would like to encounter these stimuli? So you can ask people actually, now decide how you want to schedule these stimuli to maximize your learning. And so we get a much more more direct sort of behavioral measure of um, of preference or belief around interleaving versus blocking. And that's what we've done in this next experiment. In this case, we're just looking at children in grades 1 and 5. They're again learning the penguin um, categories. But now, in this case, the way that the learning procedure runs is we don't pre-schedule the blocked and interleaved stimuli at all. What happens is that on every trial, the the child has a screen like this, and they can just pick which one of these 10 these are the Chinese names for the different penguin species. So they click on one of those. When they click on it, they're then shown an image of a penguin from that species, so they can study that and try to learn it. And they also get an audio of the name of the species. So now we can look at their actual choices. What do they do? Do they, you know, choose a particular species trial after trial after trial until they run out of exemplars from that species and then go to the next one? Do they block their experienced sequence, or do they choose themselves to interleave? So that's what this procedure allows us to look at. And so when we get the data here, we get a whole series of trials, a whole series of choices, basically, that the child makes. And we can then look at some obvious indicators here. What is the percentage of interleaving choices? So how often do they stick on a given trial to the same species that they were looking at on the previous trial? And conversely, how often are they switching from one species to another? So that's interleaving. We can just classify students as blockers or interleavers. So a blocker in this definition is just somebody who interleaves the majority of the time, and an interleaver is somebody who interleaves the majority of the time. And we can then look at even more subtle things like distance. So now, what is the average distance, separation between um, exemplars from the same category, right? So how over how many other trials do you span before you want to go back and see see a previous category on average? And so we have these three measures here, and we've put the data into a principal component analysis to derive a composite score, which I'll also show you. That's just a sort of composite measure of behavior here. If anybody has any methods question, as I say, just please do shout out.
There are two questions in the chat, David.
Okay, so sorry, I haven't got the chat open. Let me
I can read them out.
yeah, please do.
So Tracy is asking how much time between the interleaved exposures? Is it minutes, hours, weeks?
Between one image and the next is immediate, virtually immediate. This is all done, and the whole experiment is done across 20 or 30 minutes.
My real question connected to that was whether or not the complexity of the stimuli needs greater time space between interleaving. But I think you're going to get to it as you're getting into these other experiments, which I find fascinating. So yeah, thank you.
Well, but remind me, come back to that.
Sure
I'll
thing.
say a little bit more about the timing a bit later. Yeah.
And there's also a question from Nicolette asking, to what extent is visual memory ability measured, as this is likely to have an impact on ability to recognize and discern different visual elements?
Yeah, in some of this research, we have actually collected measures of visual working memory. But as far as I'm aware, I don't recall there being any meaningful associations between these. But you're completely, I mean, well, what we're looking at here, of course, is a within subjects comparison. So, I mean, obviously, from one subject to the next, there will be probably, appreciable differences in their visual memory. But here we're looking at the within subjects contrast. So that would probably largely be matched. Okay. So So those are the measures, and here now are the data. So sorry, it looks like there's quite a lot of data here. Let me go through this slowly. So first of all, in this graph here on the left, this is the interleaving frequency. So remember, we're looking at children in grades 1 and 5, and we're looking at their tendency, on each, how likely is it on each trial that you choose a different category than you chose on the last trial? And there is a significant difference here with the grade 5 children being less likely to interleave than the grade 1 children. So as you get older, people are less likely to switch from one category to another, more likely to stay within the category. Um, and that comes out also in this more aggregate measure. If you just classify someone as a blocker, somebody who chooses to, on more than 50% of trials, they're choosing the same category as they chose on the previous trial. Again, you see an appreciable difference, more of those at grade 5. The interleaving distance is higher for the younger children. Okay. I should emphasize here that even in the grade 5 children who I'm saying are sort of more inclined, have a preference for blocking, the average interleaving distance is still 3. So that it's not like every trial they stick within the species. They are actually switching from species to species. They're just not doing it as much as the younger children. Again, that's a significant difference, and the composite score shows a significant effect as well. And again, as consistent with the previous experiment, as the children get older, their classification performance gets a bit better. Presumably, their memory and their learning abilities overall are improving. So the message that I want to sort of take from these couple of studies with children is that there does seem to be a trajectory about metacognition. That for some reason, as the children get a bit older, at least in this age interval, they seem to be developing a stronger and stronger metacognitive belief that is in fact erroneous, because we know that the interleaving method is the better method. So why might that be? So I want to go on now to a couple of studies where we've looked at possible influences, environmental factors that might partly explain, or at least I suppose be correlated with this with this transition. And the first thing that we did was to look at the parents of these children. We wondered whether, is there something in parental behavior that might lead children to believe as they get a bit older that blocking is a good strategy? And so what we did to do that is this is a rather, I think, can't claim any credit for the idea here. Musi had this idea of actually just asking the parents of children in grades 1 or grade 5 to schedule stimuli that they thought would be best for their children to learn. So we've got 60 children again, this is, in China, and half of them are parents of children in grade 1, and half of them are parents of children in grade 5. And we basically gave them exactly the same experiment as you've just seen, as we gave to the children, but where we're basically saying to the parents, look, imagine that your child has got to learn a bunch of penguins. How do you think you would arrange them to optimally so that they would optimally learn those penguin species? And basically what the parents do is exactly what the children do. The parents choose more blocking when their children are older than when they're younger. So over here on the left, this is the interleaving frequency. They interleave less frequency. And remember, here we're not looking at, we're not really looking at the parents learning themselves. We've instructed them. Their task is to schedule the stimuli in a way that they think would be beneficial for their children. they choose to interleave the stimuli less if their children are a bit older. More of them are blockers for grade 5 parents. Their interleaving distance is lower when they're grade 5 parents. And again, the composite score is different as well. So that I think is kind of intriguing. I mean, it's at best correlational. I mean, I mustn't overstretch myself and claim there's a causal influence here. But there seems to be something about parental behavior which resonates with the children's metacognitive beliefs. Parents, like their children, as the children get older, seem to believe that blocking is a more effective strategy. So the next thing that we did was to look at teaching materials. And we wanted to ask the same question now. Is there anything in the teaching materials that might, as the children get older, be an environmental influence that is somehow or other persuading them that blocking is a good strategy? So we looked at maths textbooks. Right. Now, this being China, the textbooks used for teaching children at these grades are pretty standardized, and they're published by a state-run People's Education Press. And China being China, in any year there are millions and millions of children learning from these same textbooks. So we've got in total 140 odd chapters, about 40 to 50 chapters for each of grades 1, 3, and 5. And then what we want to do is we want to look at the practice problems that are given at the end of each chapter for the children as a function of whether the textbook is aimed at grade 1 or grade 3 or grade 5. And what we particularly want to do is now we want to code each of these practice problems according to the particular principle or method or formula or whatever it is that it uses, and ask, is it blocked? In other words, is it the same principle that was tested on the immediately preceding practice problem? Or is it interleaved? Is it switching to a different principle or formula or whatever? And it being 2025, of course, we turned to ChatGPT to do this for us. And we basically trained a large language model on classifying practice problems. And fortunately, this has been done by hand, not by large language models. It's done by hand in a study by Rohrer and colleagues, where they developed a kind of coding scheme for classifying problems according to whether they're interleaved or blocked. And we basically set up a prompt which trains ChatGPT to do the same thing. And we tested it to make sure that it more or less aligned with Rohrer et al.'s data results. And then we threw all these problems at ChatGPT and looked at what it said in terms of its classifications. And it shows a rather remarkable age-related trend in the nature of these problems. That for grade 1 children, for about 60% of the problems are classified as interleaved with respect to the immediately preceding question. But by the time you get to grade 5, that's gone down below 40%. So as with the parental behavior, there seems to be something in the environment here, in this case, in terms of teaching materials, that at the very least is correlated with the children's metacognitions about these factors. I mean, I can't, of course, claim that it's causal, but is an intriguing hint that there might be things in the environment which stimulate this metacognitive misalignment. Okay. I hope I'm okay for time. I've really just got one more thing to tell you about, and then very happy to pick up some questions. So I've been careful to to say that these are at best correlational findings. But we have now done a couple of studies where we've looked at interventions to try to get a bit more of a grip on the extent to which there may be causal influences on people's metacognitive beliefs and on their interleaving behavior. And so let me end then by just telling you about one study that we've done. And this kind of has three phases to it. So if you just look first of all at the pre-intervention task, this is basically what I've been describing previously. So this is students, the population here. And we get them to learn artists' styles. So they study 72 paintings. Half of them are studied interleaved and half of them are studied blocked. This is exactly what I've described before. In fact, some of the data that I showed you earlier came from this experiment, or from one of these intervention experiments. They have a test phase in which they get new paintings, and we look to see how accurately they can classify these new paintings as a function of whether they studied those artists interleaved or blocked. And let me just reassure you that for these data, for this study, we get our conventional interleaving effect. Learning by interleaving is much better than learning by blocking. We also get our metacognitive misalignment here. 60 or so % of people report that they think that the blocking strategy is better. Okay, so that's the beginning of the experiment. That just confirms some sanity check that we get what we would expect. So then in the intervention phase, we divide the participants at random into two groups, and one group is going to get an instructional intervention, and the other group is going to get a placebo intervention, which is designed to raise students' awareness about the interleaving effect. And so the way that we did that was this is really an instructional intervention. And on the left is the experimental intervention, and on the right is the control intervention. So basically what we do is we say to the students, look, in that part of the experiment that you've just done, where you learn some artists masked and you learn some of them interleaved, when it came to the test, you correctly classified 38% of the blocked artists, but you classified 67% of the interleaved artists. And here's a little graph that shows your data. Now, of course, if the subject had not shown, we did show them their own interleaving data here, and if the subject didn't show an interleaving effect, then we said, we were truthful with them. We told them that what their data looked like. And we said past evidence is very clear on showing an interleaving benefit. And we actually showed them the comparable data from Cornell and Bjork's experiment. So the subject either saw that their own data was like the reported findings, or for a small number of participants, they would mismatch, in which case, what it said was, although you didn't show this effect, the majority of students do, et cetera, et cetera, et cetera. And we try to convince them that, the research shows an interleaving benefit. And then in the control condition, they get something a bit similar. They get shown some, equivalent amount of text with a little visualization, but this is about the effects of valence material on memory. It has nothing to do with interleaving or blocking. So that's what happens in stage 2. So I've already explained stage 1, where the participants go through this whole procedure, then they get the intervention. And then, of course, in stage 3, we want to come back and see if they will now apply what we hope they've learned from the intervention, and that it will affect their behavior. And so this post-intervention task now is just our self-regulated learning task that I've already described a couple of times, where now the participants choose on each trial from what artist they would next like to see a painting. And so this is what the screen looks like on each trial. They on each of 72 trials, they pick an artist. And so they can pick Renoir or Kandinsky or whatever. And the reason that some of these are blocked out is just that this is just illustrating what would have happened, say, halfway through the experiment when the subject has exhausted all the paintings by, say, David Grossman, and now doesn't have any more of those paintings left to study, so they have to use a different category. But again, we have our same measures, the frequency of interleaving, the percentage of blockers, and the interleaving distance. And the question is, has our intervention now affected that that set of dependent measures? And so this is what we find. So if we look at interleaving frequency, we see that our control group interleave about 40% of the time, but the intervention group choose interleaving nearly 70% of the time. And that is a significant difference. So the intervention has motivated the participants to choose interleaving more often than they otherwise would have done. We also end up with more of them being classified as interleavers, or fewer of them being classified as blockers. And we see a significant increase in the interleaving distance. I mean, I haven't really emphasized this, but some of our research and research by others as well shows that, and it's not just interleaving versus blocking. The more the greater the distance in interleaving, the better. So, if you have several trials before you come back to a category, that is better than if you have fewer trials. And so you get an increase in interleaving distance. And, really nice. We're really happy to see this finding here. When you now look at test performance, you get a significant effect. It's not the most impressive effect that you'll ever see, but it is significant at 0.05. And it actually took us a little bit of effort to get the experiment set up to yield this effect. But we really wanted to show that, that a change in self-regulated behavior would translate into a benefit in learning. The participants would actually learn these new artists better as a result of the intervention, and that was what we found. Did I make it clear that these are new artists compared to the original ones? Apologies if I didn't say that. So, and coming back to the question that somebody raised about timing, I mean, we wanted to ask, a very obvious question is, does this sort of intervention effect endure for any length of time? So in one of our studies, a couple of studies, we've looked at an interval of 24 hours. It's not, it's not months, but at least it's a start in showing that the whatever the impact of the intervention is, it endures for a little bit of time. We also showed that the intervention generalizes or transfers to different, completely different type of item, so that if you're learning painting styles and then you get the intervention, that will affect your self-regulated behavior with butterfly species. But obviously, you can imagine doing doing a whole raft of follow-up studies, longer intervals, and bigger changes in materials. Going from artists to doing maths problems or something like that. So overall, I mean, I think these are just my take-home messages from this work. I mean, the obvious point is, we've replicated this, and many others have. Interleaving really is a powerful learning method. Of all the kind of findings that come out of the cognitive psychology laboratory that might have some relevance to real-world learning, this is high up on the list. People's metacognitions seem to be quite radically at variance with the actual facts of interleaving. That metacognitive bias seems to show a bit of a developmental trend, which at least in part is correlated with some environmental factors. And we're planning intervention studies to look at, to look at how we might go from correlation to causation. But at least we do know that there are potential causal influences because our training intervention does change people's behavior. So I'll leave it there and happy to take any questions that you might have.
Thank you, David. That was fascinating. And there are a lot of questions in the chat already. So if that's okay, I'll just read them out.
Well, look, I'll unshare and then shall I unshare and then
Sure. Then we can see each
I'll
other.
be able to read the chat. Does anybody want to read out a question? Put your hand up if you'd like to read out a question. Yeah. Do put your hand up if you'd like to actually read a question out loud. Otherwise, I'll just work down this. So, how much is the time? So, yeah, I mean, going back to this timing issue, I mean, in the actual learning phase of the experiment, it's all happening, trial after trial after trial with over very short intervals. The only place where we've sort of looked at longer intervals is that what I just described, where we have a test after 24 hours. Yeah. Choice might be between choice of interleaving or blocking, or are the students using their knowledge of the written character or the audio as addition? Tracy, I don't know whether you'd like to unpack that question a little bit. What were you getting at there?
Sorry, I was just thinking aloud when the second experiment actually added on this other elements of having the written word and the characters and also the
The name
audio.
of the
Yeah, so
name
that
of the
sort of
penguin
changed the
species.
experiment a bit. So I was just wondering if that changed things a bit. But I'm actually very fascinated by Panos and Heather and Elizabeth. There's a bunch of other questions here that have a lot to do with your pondering about the students getting older and their metacognitive shifts. There's a lot of really smart hypotheses here about why, and some about taxonomies and categorization skills and how things change in the brain. And I'd love to
Oh, so you're
hear
referring
those
to
people.
questions further down. Yeah.
Yeah,
Sorry.
there's questions further down that I'm just
Yeah.
looking at and
Okay.
just
I'll try
thinking,
and.
what smart questions there. So
Okay.
I'll let them speak.
Um, I wonder if the metacognitive effect of blocking learning preference might be linked to a belief that blocked learning is more closely linked to taxonomic categorization. Yeah, that's a really nice point from Panel. That I mean, there may be something where the participants know that these are items that come within a taxonomy, and that is kind of prompting their choice of the blocking strategy, if I understand that right. Um, and I guess that makes me wonder what would happen if we used stimuli that weren't quite so obviously sort of taxonomically structured. Um, I'm thinking aloud here. I mean, yeah, I mean, in any kind of category learning, I think that taxonomic structure is going to be available for the participants to build on. So I think that's an interesting point. I mean, Panos, if you've got any thoughts on how we could test that, do say. Yeah, Panos, you've got your hand up.
Yes, yeah. Can you hear me? Yeah,
Yeah.
yeah. I don't have any thoughts of how that could be tested. Uh, I will need to have a thought about it. But I will be very, very, very interested to, since this study was done in China. As far as I know, but correct me if I'm wrong, Chinese educational system, being socialist, will be more biased towards categorization, stemming from Luria's research and etc. So I don't know if,
Yeah.
yeah. So
I mean, one answer that I think might be right. So you can look at interleaving and blocking in purely perceptual learning problems where you're not learning categories at all. You're just trying to learn to discriminate complex and unfamiliar stimuli. Like, for example, you're trying to learn to discriminate phonemes or words or something in noise. And I believe I'm right in saying that, you get an interleaving benefit even for something that's just perceptual learning. So the participants don't have to respond. They don't have to make a taxonomic response. They're just really learning the features of it. So that might be one possible hint that there's a bit more going on than just the taxonomic structure. But yeah.
Thank you.
There was a question here, Elizabeth, could perceptions of difficulty be involved in the misconception? I might perceive it as more difficult to be doing the comparing and contrasting on the fly when interleaving, and thus feel as if yeah. Now, this is absolutely right. I'm sure this is right. I mean, you've come across the phrase, I expect, desirable difficulty, which is Bob Bjork's term for manipulations or variables or factors which sometimes which can make learning a bit harder, but which are ultimately beneficial. So spacing being a perfect example of that. So spacing, excuse me, I mean spacing, which is obviously a little bit linked to this manipulation here. Um, if you have to do a driving lesson once a week compared to what every day, um, it makes it harder because every time you get behind the wheel of the car, a week has gone by and you've sort of forgotten what you were learning a week ago compared to when you're doing it a day after a day after a day. But that is a desirable difficulty. And I think there's probably something going on here as well, that it feels as if it's going to be difficult to learn from this interleave method, but that difficulty is actually good for you. Yeah. Yeah. Um, uh, Any other questions that I should be looking at?
There were a
I
couple
wonder
of
if
questions
belief.
about the cultural effects of parenting and the notion that perhaps many children are raised with the idea that you need to finish a task before moving on to the next one. And perhaps that is why the parents were encouraging the older children um, to block rather than interleave.
Yeah, I see what you mean. That if you were, um, I want to present you a block of things, and I want you to completely master it before you go on to the next. I mean, yeah, I mean, the parents might have believed that this task was more tractable than it is. I mean, it's really difficult. Nobody's going to get anywhere near 100% correct in this task. So if you have some sort of sense of wanting closure before going on to something else, you could see an argument for preferring blocking. But again, I mean, I would say that might be a motivation, but it's an erroneous motivation, isn't it? Um,
And Heather's got her hand up.
Please, Heather, yeah.
Hi, thanks. That was really interesting. Going back to your idea of spacing, my gut feel would be that there may be an initial benefit to blocking followed by interleaving. So I was just wondering whether there might be a different way of sort of teasing apart the frequency of blocking versus interleaving. So for instance, if you divided your stimuli into quartiles or quintiles and you looked at the percentage of blocking in the first quintile relative to the fourth quintile, you might get some nuances into whether, there's a different strategy. Because I think you did suggest that the grade fives were, although they were into, or I can't remember the subtleties, but there was some sort of age differences there that you might
Yeah.
not be picking up on because of
Yeah.
the
Yeah.
outcomes.
Completely right. I mean, I think that so what the evidence shows is that in a task such as we're using here, the best thing to do for your learning is to maximally interleave.
Mm.
But I think what you're saying, forgive me if I'm putting words into your mouth, is, I mean, what happens if you look at a sort of much shorter amount of learning? I mean, if, if I'm only going to see a few trials, would it still be the case, um, and that I don't know. I don't think people have really looked at what would happen with really, quite, just a really small number of trials. When you have anything like a large number of trials, it just looks like the more interleaving, the better, which is itself kind of weird, really, because that must make it very difficult. Feels like it would make it very difficult.
Yeah,
Feels
yeah.
to me.
I think I wasn't quite saying that. I think what I was trying to say is that so for instance, when you're first learning a new concept, you might want that blocking to gather
Oh,
the
right,
similarities.
right.
However, as you continue learning, there's benefit of almost sort of testing your memory and saying, okay, I know who Georgia O'Keeffe is. Can I identify it later on? So you might find that there might be a more complex strategy of that's you benefit
Right.
from initial blocking. So grouping
Yeah.
maybe the first 3 stimuli of the same person together, but then later sort of testing your knowledge. And so in
Yeah.
your analysis, if you split that apart, maybe you might see an interesting pattern emerging.
Yeah. I mean, and the sort of way that maybe would be quite fun to look at that would be, I mean, suppose I got people to come in one day and I give them, I give them blocked and interleaved. And then I get them to come in the next day and do it all over again, but with some new paintings, but by the same artists.
Mm-hmm.
Right. And then I do that on a third day and a fourth day. I think what you're suggesting is that by the time they're beginning to actually master these artists quite well, you might then find that actually interleaving is not the ideal. Right. So you might want to start interleaving on day one. But by the time you're getting to be quite expert, there might be now some benefit to blocking.
Mm.
Yeah.
I think the other way around, actually, but that initial blocking would be good.
Oh, right.
And then for
Or
interleave.
initial
Yeah,
blocking.
yeah,
Yeah.
yeah,
Well, as far as I know, nobody has looked at this where
yeah,
you actually experimentally manipulate
yeah,
and have a change in the organization. That's a really
yeah,
nice idea,
yeah,
actually.
yeah,
starting off blocking and then going to more interleaving or the other
yeah,
way around.
yeah,
That's a
yeah.
really nice idea. I'm going to make a
Mhm.
note of that.
Cool.
Thank you. Yeah. Um,
The chat is exploding, but we only have 10 minutes.
um, Very young children learn a lot through play and exploration, in which a lot of stimuli are mixed and therefore interleave. The idea of mastering a particular set of material comes later. Yeah, that's a nice thought. Thank you, Jonathan. Um, yeah, subtle differences. Somebody asks, could you tell us more about the word tasks experiments and how these? So this, I think, is referring back to the meta-analysis that I mentioned at the outset, where there's this what seems to be a bit of an outlier with word stimuli, which actually showed a negative interleaving effect. As I recall, it's a little bit of a hodgepodge of studies doing, using some slightly different kind of learning procedures. I think some of them might have been spelling, some of them were paired associate learning, and all they really had in common was that they used word stimuli. So I'm not really sure that there's a lot to take away from that negative finding. Um, yeah,
It would be a good dissertation project if any of our master students are listening today. They could.
absolutely. And find an applied learning problem, spelling or whatever it might be, word pronunciations, irregular words or something, and have a go. Yeah.
We have 1 more minute. Do you want to choose one more
Um,
question?
uh, um, So I'm just so many.
How about David, could we post your email? Or
Oh,
people
please
can
do.
look you
Yeah,
up,
yeah,
right? Because you're at
yeah,
UCL, so people
yeah.
can
It's just
Google
D.
your name and follow up with any other questions via email.
Yeah, I do have a namesake, so um, get the right email address. I've put it in the
The
chat.
right David Shanks at UCL.
Yeah,
Amazing. Thank you so much, David. This was a fascinating talk. As you can see, the chat is still exploding. So this and all our talks are posted on the YouTube channel, so you're welcome to watch again. And we're looking forward to seeing you next week. Next week, we will have another fascinating speaker. David, thank you so very much for your time. And thank you, everyone, for your continued support of our seminar series.
complete pleasure. Thanks.
See you next week.